Hi, welcome to my channel. In this video, we want to solve the following problem. PQRS is a square inscribed in a circle of center O. A second circle of center O1 is tangent to the first circle at T, where T is a point on arc PQ and is closer to Q. Let P1, Q1, R1, and S1 be points on the circumference of the second circle such that PP1, QQ1, RR1, and SS1 are tangents to the circle. Given that PP1 equals 12 units and RR1 equals 12 square root 3 units, the goal is to find the length of QQ1 and SS1. And now for the solution. First, recall that if two circles are tangent at A, then the centers of the circles and point A are collinear. Since the two circles are tangent at T, OTO1 is a straight line. Denoting the radius of the circle of center O as R, and the radius of the circle of center O1 as R1, the length of OO1 thus equals R plus R1. Next, connect O to P and connect O1 to P. Label the angle between OP and O1 as alpha, and then consider triangle POO1. Let's apply the law of cosines. Given a triangle with these dimensions, the law of cosines tells us that a squared equals b squared plus c squared minus 2bc cosine alpha. Applying the law of cosines to triangle POO1 gives us PO1 squared equals OP squared plus OO1 squared minus 2 times OP times O1 cosine alpha, or PO1 squared equals R squared plus R1 whole square minus 2R times R plus R1 times cosine alpha. Following this, connect O1 to P1 and then consider triangle PO1P1 and the second circle. Recall that if AB is tangent to a circle of center O, then angle OAB is a right angle. Since PP1 is tangent to the circle, angle O1P1P is a right angle. By Pythagoras theorem, we have PO1 squared equals O1P1 squared plus PP1 squared, or PO1 squared equals R1 squared plus PP1 squared. Equating the two expressions for PO1 squared and expanding this term, we obtain this lengthy expression, which simplifies to PP1 squared equals 2R times R plus R1 times 1 minus cosine alpha. Next, using the identity, cosine 2 theta equals 1 minus 2 sine theta squared, or 1 minus cosine 2 theta equals 2 sine theta squared. We write 1 minus cosine alpha as 2 sine alpha over 2 whole square. Taking the square root, we obtain PP1 equals 2 square root R times R plus R1 times sine alpha over 2. For simplicity, let K equals 2 square root R times R plus R1. So we have PP1 equals K sine alpha over 2. Next, connect O to Q and label angle O1OQ as beta. By similar arguments, we can show that QQ1 equals K sine beta over 2. Since PQRS is a square, beta equals 90 degrees minus alpha, and so QQ1 equals K sine of 45 degrees minus alpha over 2. Following this, connect O to R and label angle O1OR as gamma. Then RR1 equals K sine gamma over 2. Since gamma equals 180 degrees minus alpha, we have RR1 equals K sine of 90 degrees minus alpha over 2. Finally, connect O to S and label angle O1OS as delta. Then SS1 equals K sine delta over 2. Since delta equals 90 degrees plus alpha, we have SS1 equals K sine of 45 degrees plus alpha over 2. Using the identity, sine of 90 degrees minus theta equals cosine theta, the expression for RR1 becomes K cosine alpha over 2. Next, using sine of A minus B equals sine A cosine B minus cosine A sine B, the expression for QQ1 becomes K sine 45 degrees cosine alpha over 2 minus K cosine 45 degrees sine alpha over 2, or 1 over square root 2 K cosine alpha over 2 minus 1 over square root 2 K sine alpha over 2. Therefore, QQ1 equals 1 over square root 2 RR1 minus 1 over square root 2 PP1. Substituting PP1 equals 12 units and RR1 equals 12 square root 3 units, we obtain QQ1 equals 1 over square root 2 times 12 square root 3 minus 1 over square root 2 times 12. Simplifying, we obtain QQ1 equals 6 times square root 6 minus square root 2 units. Next, using sine of A plus B equals sine A cosine B plus cosine A sine B, the expression for SS1 becomes K sine 45 degrees cosine alpha over 2 plus K cosine 45 degrees sine alpha over 2, or 1 over square root 2 K cosine alpha over 2 plus 1 over square root 2 K sine alpha over 2. Therefore, SS1 equals 1 over square root 2 RR1 plus 1 over square root 2 PP1. Substituting in the values for PP1 and RR1 and then simplifying, we obtain SS1 equals 6 times square root 6 plus square root 2 units. Therefore, the solutions to our problem are QQ1 equals 6 times square root 6 minus square root 2 units, and SS1 equals 6 times square root 6 plus square root 2 units. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.